We're solving problem 25 from the AMC 12A from 2022. A circle with integer radius r is centered at r, r. Distinct line segments of length ci connect points 0, ai to b, 0, for I is greater than or equal to 1 and is less than or equal to 14, and a tangent to the circle where ai, bi, and ci are all positive integers, and ci is less than or equal to c2 is less than or equal to ... to c14. What is the ratio of c14 to c1 for the least possible value of r? So this is a pretty big problem. 25 obviously. So we have this graph here, and it's the circle. It's draw it out first. I'm not that good at drawing circles. It's centered at here around r, r. Okay, and these are all right angles with length r. Okay, and okay, now we have a lot of possible tangent lines here, a lot, and it restricts us in this problem because it only have integer coordinates. There would be infinitely as many if there weren't integer coordinates. So there's going to be a big tangent line around here, say, with endpoints of, say, A and B, like that. This point of tangency we can call point P, and these points of tangency on the x and y axis call S and Q. Now, we can already find the coordinates of these points in relation to the circle. Okay, so we know that point A, that's 0, comma, the height of A, called a variable lowercase a. Same thing for B, lowercase b, 0. And for Q and S, this Q is r, 0, in the terms of this, that length is r, so we call it r. S is 0, r, respectively. Now, well, let's see. We know that BP, the length BP, is equal to this length, BQ, because both are touching tangency points at the circle. And this is basically B minus R. Alright, this is B minus R for the reason that since point B is at B and B, 0, we can now get an expression in length. Since this coordinate is R, this becomes B minus R. Okay, same thing. AP is AS is A minus R. Okay. See here. C. Well, yeah. Obviously, duh. C is equal to. Oh yeah, because we don't have a C yet. What we can do here is set a value of C right now. We have this big angle. Let's let that be the hypotenuse. C is equal to AB is equal to AP plus BP equal to AR. That's all just equal to these two lengths added up. A minus R, B minus R. Now, we can also find this length by Pythagoras' theorem. C squared is equal to A squared plus B squared. Since we have a C squared there, it's only fitting for us to square here, where that becomes a big square. Okay. And now that we have that, well, we can just basically set those two values equal to each other. But first, what we should have done was, since we knew that C is equal to A plus So C was A minus R plus B minus R. That becomes A plus B minus 2R. Now we square it. Yes. Okay. We can set these two equal to each other. So A squared plus B squared is equal to A plus B. And we're clumping this together. So one whole thing, because it's easier for us to just have that in a square and then subtract 2R squared. Right. You want to multiply all of this out, and when you subtract like terms, this becomes kind of a Diophantine equation. AB minus 2AR plus 2BR plus 2R squared is equal to, plus 2R squared is equal to 0. Okay? This is, in fact, a Diophantine equation. This is a minus, my bad. But, yeah, this is a Diophantine equation. We've done these in my Simplify videos. So what you want to do is, well, factor this A together to become A times B minus 2R. And then minus, factor this 2R out. Side is this B minus, well, we want to have the same thing in here, 2R. So we write that, B minus 2R. And when you multiply this out, this 2R squared, whole thing squared, so we have to add it on the other side, 2R squared. Okay. That is a big equation, because we don't really need any of this anymore, but now we have that. And similarly, when you draw a tangent line down here, you can go through the whole process of doing that again, and it will be flipped, but since you're squaring it, you're still going to get the same result down here. We see that, well, actually, we know that there's 14 solutions because I only has a maximum of 14. Okay, so we have this, and we know there's 14 solutions. Solution for A minus 2R, and we also know A and B are greater than 0. That has to be it. So you know that A minus 2R is less than 0. Okay. We're starting to really get somewhere in this problem. So if that is true, we know there's 14 total factors, and 7 of them will be positive, 7 will be negative, because it will be evidently flipped around. That's how you get negative values. Okay. Now, okay, if we create a graph, say, for our R, our 2R squared, a whole thing squared, and the positive factors, the number of positive factors, we can start out as 1. All this becomes 2. There's 2 positive factors here. Okay, calculate 2. There's now 8 here. And then there's 4 here. When there's 3, this might be a bit hard to calculate, but there's 18, which is 2 times 3 squared, which is 6, because, yeah, this is how it works. Yeah, you just find factors with these numbers. 4, 4, this is 32, which is 2 to the power of 5, still 6. 5, this becomes 2 to the power of 1 times 5 squared, also 6. And then when you get to 6, you get 72, which is 2 cubed times 3 squared. This is 12. Okay, 12. So our number has to have less than 12 factors here. Now, when you have r equals plugged into that formula, you get basically a minus 12 has to be less than 12. So that is a very big conclusion. So now we can two things out. Either A over B or B over A. Now, whichever works is best because there's positive and negative factors, but now, well, you have to max either these two. It's not because they're positive or negative. It's because there's actually two graphs. A circle like going like this, and a graph that could look like this. That's why there's an inverse. Or that's how the inverse is graphed. So our maximum value is a minus 12. Set it equal to that 2r squared, 72. A minus 12 is 72. We want our low value for b minus, because we have an a minus 12. We need that. This is going to equate to 1, our lowest value. Okay. A is 84. B is 13. We have our highest set at this point. And if we want our minimum, that's how we get our maximum. Maximum over minimum. We have to obviously go into negatives. A minus 12, negative 8. B minus 2 is 9. Okay. So, you solve, you get A is 4 and B is 3. That C1 is 5 through Pythagorean triples. Through this Pythagorean triple, we have 85 over 5 is our answer of 17 for this problem.